Okay guys, am I audible over here over the web? Yeah, great. Okay. 1 minute. Okay, so by the end of today's class, if you have some sort of answer for these three questions, I think the motive of the class will be met. Okay. The first question is, what is this container? And the second one is, why is it required? How does it help? Right? And because, as I said, actually I say it very much often that containers are very, very important. What is my reasoning behind that? Okay, so these are the three major questions which I am trying to address now. Okay, so and I try to do it in mostly non-technical way. I'll not say that it is fully non-technical. I'll basically tell that it is okay, not that great technical definition of Docker will not be giving it today. Okay, now before understanding container, let us try to understand how normal applications are deployed, are executed. I'll not say deployed. Okay, and what does it take? And from there we will take a scenario. Okay, and from this scenario we will identify what is the problem with the current approach and why container could help here. Right? Okay, now how normal applications are being deployed right now? First thing is very sample process, very normal kind of a process. Okay, we find our physical server. Yes, we install OS, whatever OS our application requires, and then some additional required softwares and configurations. Okay, so what do I mean by all of this? I'll take some language example so that it is familiar. Okay, I want to run a Java web application. Okay, so this is what my company is developing. So first thing is I've taken a physical server, and let us assume that it is 24 GB RAM and 1 terabyte hard disk. Good. Okay, and let me also code the processor over here. Let us say it is quad core. Okay, good. And now on this I have installed Linux, or to be more specific, Ubuntu. Right? And my third stuff is I'll be installing Java, Tomcat, and one database which is MySQL. So this is what I'll do. Yes or no? Yeah. Similarly, if you take .NET application, let us assume that it is not Java, it is .NET web application. All right. Then let us assume that we have the same hardware configuration, whatever I have typed. So one I am not writing, same as above. So let me write same as above. Okay. And then we'll be installing Windows Server 2016 or any server OS for that matter. Right. And then I will be configuring IIS server, right, and Let us take it as Microsoft SQL Server. Yeah, we can make this list for every technology. Do you agree to that? Yeah, any technology. Let it be Python. I'll be writing a different stack. Okay, Python on Apache server. Okay, Django installed, right, and some MongoDB database. Similarly, Node.js application. I'll be telling one more stack. For every application, I'll have something like this. Okay, so first thing is your system, and the next thing is basically what are the requirements of it, right? So this is simple, right? No one has any queries around this, right? Now let me tell you what is the problem now. Okay, what does it take? I think we have written it. The 1 2 3 steps is what does it take, right? Now for Java application, okay, I have two Java applications. So how many servers do I need based out of it? Two servers. Good. Now the system which we are purchasing is 24 gigs of RAM. Okay, but let us assume that each Java application is consuming only 4 gigs, but we have 48 gigs of memory with us. Is it not wasting revenue? Yes or no? Yeah. So what could be the solution for this? The concept that has came out to solve these kind of stuff so that we can use hardware to its potential is virtualization. Okay, and to be more specific, we are speaking about server virtualization or system virtualization, whatever you call it, right? So what we would do in this case is we'll take 124 GB system. On that we will install the virtualizer software like vSphere or whatever the VirtualBox software is, and then we will be installing two operating systems in the same physical machine. Yes. Okay, now I am going to propose an approach which is better than that. That's why we use containers. Is the scenario set? This is a sheer waste of money. Do you agree to this? This approach is a sheer waste of money, right? What is the solution for this? We take virtualization. So we'll take a physical machine, 124 gigs of RAM, and in that we'll be installing, let us assume I will be installing two applications, two operating systems, right? Or three operating systems, because each takes only 4 GB. And my hardware is completely utilized. Okay. So virtualization, which is like vSphere, VMware, okay, EMC square, whatever it is. Okay. These virtualization techniques are far better than using it directly on a physical machine. Now what I'm trying to tell is container is better than server virtualization, better than VMware. But when I say better than VMware, there is some perspective around it, not better in all cases. Do remember that. When I say better, better in some perspective, not all. This is our context, or this is the background by which we discuss our class today. Okay. So this is known to all. If you know this, rest of the class is simple. If you understood this. So till here, do we have any doubts? I have not introduced to Docker also. I've just put couple of questions or three questions, whatever you are seeing over here. The questions which I want to address in the class is what is container today? What is container? Why is it required? And how does it help? For that, I have taken a normal scenario where we go and procure the physical servers, and then I have listed out some applications. So let us assume your company is developing Java web application. Then what is the stuff that generally is done? So they would be installing an operating system, any Linux or whatever operating system it is, and then they will be installing the required softwares like let it be Tomcat, WebSphere, WebLogic, whatever it is, to make your application work. Similarly, if I take the .NET application, they will be installing some other stack, Python some other stack, but this process is common. Okay. Now the problem here is I'm taking physical server, right? And let us assume that your application is running only with 4 gigs, but you have 24 gigs of RAM. It is a sheer waste of money. Why? Because To purchase this server, your company has to invest upfront. Yes or no? If I have to purchase the server, I have to pay it before I start using it. Yes or no? It is much like your car, right? You have to pay certain amount. You will have upfront costs. Okay. So now we said that what could be the better way of dealing about it, and then we have discussed about something called as server virtualization. I'll be discussing that in more detail. For the people who don't understand virtualization, I'll be discussing about in the more detail. But if this example which is mentioned over here is clear, we can proceed. That was the whole argument, right? Okay. I have not it has said anything about container. నేను కంటైనర్ ఇంకా ఇంట్రడ్యూస్ చేయాలి క్యారెక్టర్ ని వచ్చాక మాట్లాడుకుందాం దాని గురించి. రైట్. ఓకే. So let us add this in. Do you all agree to this? Applications run businesses, especially for our IT firms. That's how we are getting paid. Okay. We deploy applications and applications gain revenues, and that's why you and me are paid. Let it be any application. Okay. So and now these applications requires servers. Quite a simple stuff. Okay. Applications drive revenues and applications require servers. Now basically when I have discussed about the first model which I have discussed, okay, you have to go for procurement, which is purchasing. Okay. And whenever you want to purchase a server, the first thing is it takes some time, and the next thing is you will have upfront cost. That is what is written there as upfront capex, which is upfront capital investment by your team or company or whatever it is, right? It doesn't stop there. You will have ongoing cost also, like maintenance of it, putting it in a room with all the security and temperature. When you see in your data centers, you will have a chilled room over there with servers being placed in a rack and all of that. Okay. You will have all of this. Now the problem is, okay, in this the problem we have identified, our application is not going completely. Okay. It uses only 4 GB, but we have 24 GB of RAM. It is waste of investment. So what we do now is we will go into a model which is called as virtualization, and that virtualization is also called as, or the softwares which do this virtualization are called as hypervisors. So VMware is a hypervisor, VirtualBox is a hypervisor. Okay. Microsoft products name itself is Hyper-V. So any software that helps you to, okay, create a machine within your machine or create an operating system within your operating system is called as a hypervisor, right? So for example, you install VMware in your Windows machine, and in that you can install Ubuntu, right? Yeah. So but actually what you have is you have a laptop with some operating system, and you are installing some software which helps you to create one more operating system. Yeah, it is not a physical machine, that's why we call it as a virtual machine, right? So the software that allows you to do this is hypervisor, right? Now let me draw the scene. Okay, later on I'll copy that onto the OneNote and I'll share those things by the end of the class at one shot to all of you, right? So let us go with our first model, which is physical machine. I have a huge physical machine. Okay, let me draw it like this. Yeah, and in this I'm installing an application. I'm installing an application. It uses only this much. Okay, but okay, whatever is green is free space. Oh, shit, man, I think I've messed it up. Okay, fine. Okay, whatever it is. So I'm unable to do this correctly because I've messed up some settings. What are they? Yes. Yeah, we have this area. and within this our application is just taking this, right? And the total free area which we have is, and the actual utilization that is happening is, so this much you are wasting. All right, does it make sense? Okay, our application is that yellow box. All right, but our system is much more capable and than that. But if you know about production servers, on production servers you generally don't install two applications. You will never do that. All right, so this is waste of investment. Now to utilize it better, what the companies have done is, okay, they have said that we will go to the other and better model. What that is, okay, let me take a physical server, right? Okay, let me do one thing. Let me take a physical server, and on this physical server I'll be installing a software which I would call it as a hypervisor. But since most of you know a word which is VMware, I'm writing VMware directly. But it could be anything. It could be vSphere, it could be VMware, or it could be any software. Okay. Now, using this, what I would do is I will be creating virtual machines over here, right? Rather than having 24 gigs, I'll be giving only 8 GB to the virtual machine. Okay. And in this, I'll be launching my application. Okay. So now you can find out what is the useful area and what is the useless area. So this is basically being free or used by your system, all right? And this is utilized. And now you can also install one more application which has nothing to do with this. So you go ahead and you would be installing one more machine or one more application over here. So now you see the stuff. I'm not going to fill it again and again, but yeah, I think you got the essence of it, right? This is my VM1 and this is my VM2, and within VM1 and 2 I have app1 and app2. On the physical server where we used to install only one application, now we are able to install two, and probably we might have some space left if there are still some less numbers, and I can go ahead with one more installation. Is it not a better approach than going with the first one? This is why we have VMware. The whole purpose of the existence of the VMware or the virtualization software is all about this. Okay, because we don't want to waste our memories, okay, only for one application which is confined to some things, right? This is hypervisor model, the second model, the second generation of virtualization. Okay, initially when it started it was not very much capable, but now it is very much capable because most of the production servers are now on virtualizations, right? Even the cloud which we use, let it be AWS or Azure, is one kind of virtualization like this itself. So in the cloud, if you are creating the Linux machine, which is a virtual machine, exactly it uses its own hypervisor. It might not be a VMware, it might be AWS proprietary software or Azure's proprietary software, but the concept is exactly the same thing, right? So from 1 to 2, is there any improvement? Yes. Now in this second one, I want to find out what are the problems. Okay, are you seeing any problems here? In that case, we'll take a bigger virtual machine. That's fine. Scaling up is even not possible in physical machine, right? Yeah. So now let us see what steps do we do for creating the VM1. What are the things which you do? If I have to create VM1, what are the steps? Again, the same thing, right? Install operating system, okay, and then install or configure necessary softwares. Okay. Why we have done VMware? Because we want applications to run. So what is your focus here, application or operating system? Application. But what is that you are doing most of your work on? That is the first point. Right? And the second one is, I want to run my application. Okay, how much does the operating system consume? Will it get most of the memory to the application or to the operating system? If I'm speaking about memories of scale 4 GB or 8 GB, 50% of it is at least consumed by your operating system. So why do I need to waste that? This was the thought process. Okay, and now this is just consuming. Now let us assume that I'm speaking about Red Hat Linux or basically Windows operating system. Red Hat Linux or Windows operating systems are not free operating systems. You have to pay the license costs. So you have to pay 2 license costs for your 2 applications. Can I avoid all of this? That was a question. Okay, so can I basically see a virtualization software where I will not be consuming more memory or more of my system's power on operating system, and my application will be getting most of it, and I will be avoiding costs like operating system licensing costs? Can I basically find out a solution for that? Okay, is the question clear? From first to second we came, it is better, undoubtedly it is better than really running one application on a physical machine. But here the question which I'm trying to ask you is, my focus is application or operating system, and all of you have, most of you have answered that it is an application. So when your perspective is application, if me perspective application ainappudu, why do I need to waste my memory on operating system? Why do I need to waste my licensing costs on operating systems? Because my focus is application, not operating system. This was the question, and this question is answered by a technology called as container. That's it. This technology is answered by a concept called as containers. And container is has become very much popular with an organization called as Docker. But mark my words, container was there in Linux kernel from day one. It was heavily ignored area. Container lo Linux lo kottaga em rala. The day Linux kernel was developed, container was already there, but it was a heavily ignored area. No one really used to worry about that because everyone was fond of this, the second one or the first one, but they have not thought of the third gen where we want our applications to be dominant than really the operating system. Okay, now in the second image, how many operating systems we have? 2 operating systems, and here also we'll have one more operating system, right? Totally we have 3 operating systems. Okay, if your hypervisor can completely create virtual machines, even that is an operating system. So here we have n virtual machines plus 1 operating system. Okay, and each operating system comes with its own overheads because it has many things to be done. Okay, so the next technology should be minimalistic operating system. Yes, because if you want to save cost, where will you save from? Okay, so if you see yellow, there is a lot of green over here. I want to avoid most of it. I will not say avoid all of it, but avoid most of it, and my application should be the prime focus in whatever I am running, not really the operating system. Okay, fine. Is it making sense? Yes. So that will be our next scene which we'll be discussing over here. Now come back to this. So then we came across a technology called as hypervisor, which is VMware. And in VMware we are running applications, everything is good, yeah, but there are some problems with hypervisors. Let us see what are they. So let us assume that this is what you want to achieve. You want to install 4 applications on your physical server. Now what will we do? We will create 4 virtual machines, and on the 4 virtual machines we'll be installing 4 operating systems, and on top of that operating system we'll be installing the application, right? So this is what we do. Now I'm not saying it is troublesome. I'm trying to say that can't be optimized. The question is not having problems. The question is there a better way? All right. So that concept gave birth to a thought process which is called as a container, which is called as a container. Now let us see what container does. container will not have 4 operating systems for 4 different applications. Yeah, even if it has a very minimal operating system. Now if you see, are we doing any installations over here? We have some box which is in blue. That blue box is what we call as container. Now let us try to deep one level deeper into it, see what is there. Which is like looking better? Yeah, here basically what would happen is, okay, for your application, this container will look as if it is a full blown operating system. For the app which is running in the container, it would look like container is an operating system. For your actual operating system, your container will look as if it is one process. So let me reiterate my words. Okay, so I am running Notepad. What is it for Windows? Windows ki Notepad enti application, and when you run the application, what will be created? What is this? Process. So whenever you are executing anything, what you get is process. So your operating system creates or basically allocates memory to process, right? So if you go to the container technology, for your operating system, container is a process, but for your application, container will look as if it is an operating system. దీనికి ఇది ఆపరేటింగ్ సిస్టమ్ లాగా అనిపిస్తుంది, right? It is an illusion. Okay, I'll tell you how that illusion is created probably at the later point of time when we have one level deeper view of it. But for your application, you have an isolated area of executing your applications, right? And for your operating system, it is nothing but one simple process. So whenever your application needs some hard disk access, okay, it asks container. Container is much like operating system to your application, and this container doesn't take any decision. It indirectly asks your parent operating system. So you don't have an overhead of installing multiple operating systems within this, right? The same thing happens with all of them. And now what you can do suddenly is, on the physical server where you have installed 4 applications with 4 VMs, now you don't have operating system overhead. So let us assume that your application requires 4 GB and your operating system requires 4 GB of memory. Now probably you can manage probably with 4.5 or 5 gigs. So 5 into 4, 20, you still have 4 GB left, so you can launch one more container. So on the same physical server, you can reuse most of it and host many applications which run in their own spaces. That's the whole idea. That is what a container is. A container is an isolated area for your application's execution. That's what a container is. Okay, isolated ante enti? When my application is running, it will give whatever my application requires, right? So this container will not be able to access anything in this container. That is what an isolation is, right? So isolation is keeping separate. So an application which is running in this container has nothing to do with whatever is happening over here. It has no relation, right? For an application, it looks like everything that is being asked is done by this container, but actually your operating system is doing it. So you don't have multi OS installations. Yeah, and in that container, what we have is a very minimal Linux kernel. In that container, what we have is a very minimal Linux kernel. And if you know Linux kernel, it is used in many places. 1 rupee coin boxes, your Apple or not Apple, wearable devices, IoT devices, right? So Linux kernel doesn't mean that it is a server. It is a very thin operating system. But when you add Ubuntu or Red Hat Enterprise Linux, it becomes fat. But actually Linux minimalistic Linux kernel is very small, very small. That's what this technology leverages, right? How does it work? Let us worry about it at the later point of time, right? Now let me finish this. I'll answer you. I'll take your questions. Yeah. So now if you observe this, see what is happening. All this operating system cost we can avoid, right? And then our CPU utilization, which is unnecessary going into, or CPU or disk utilization, whatever is going into your operating system, you can save and you can retain it for your applications. Now One thing to remember is, since we are basically saving on operating system, what do you say, we don't install operating systems, and we directly basically put our containers, our applications in the containers. Don't expect the same level of administration as what you do on VM. How to do patching, not at all your concern, right? Because you have a thin OS version, so don't expect the same level of administrative stuff. Docker container looks very good when you are thinking about application, but when you are thinking from bottom up, how do I get network and how do I get all of that, you will get all of that, but these are all virtual technologies. They are not as strong as what your VM is. So for example, in VMware, okay, I can basically share certain things between systems, right? I can get different, what do you say, different kinds of extensions, because it is basically meant because you're installing operating system. Okay, how can I basically do hardening of the system? Administrators do something called as hardening of OS, because it doesn't get into any security traps, right? So how can I do it on my container, right? So it is not about administration, it is about applications. It is all about applications. Docker container technology looks very good when you are thinking about application, not administration. Yeah, since it is application first scenario, the administration over here slightly deviates from the normal stuff. Okay, how you maintain your operating systems is, I will not say completely different, is slightly different from how do you maintain your containers, right? So now if your VM has gone wrong, we will try to correct it, right? Yeah, if you go to the cloud, will you try to correct it? Cloud technologies lo VM ni correct chestama? Generally we don't, right? We probably might spin up one more virtual machine very fast so that our application continues. The same is the concept with Docker containers. Container not working, bring up one more. Okay, we don't try to fix it. Yeah, if it is continuously failing due to some reason, we'll do that, but sporadic issues we generally don't tend to mind about it. So how can I basically maintain all of this stuff? That's the whole journey. So in the container, how will my container get an IP address? Okay, for example, I am launching two applications. Okay, both are web applications, both use 80 port. So how can I access? Okay, so whatever data that is being generated in this application is in the container. How can I take backup, right? What if my one container is in here in this machine and other container is another machine? How can these two speak? There we learn networking, but the whole concept is all about containers, and we discuss this as application first. If your thought process is application first, wonderful. If your thought process is administration first, it is not as good as what you think of VMware. So don't compare this with VMware. Okay, so basically it is isolated area for execution of your applications. That's it. It is not an operating system. Once it is an operating system, you'll get a lot of advantages, right? Here you don't have a full-blown operating system. Yeah, you can make it full-blown operating system because of the technology which it uses, but making it as a full operating system is no different than using VM. So that's why we want to have a minimalistic things over here. Okay, మన అప్లికేషన్ రన్ అవడానికి ఏం కావాలో అవే ఉంటాయి అందులో, ఒక్కటి కూడా ఎక్స్ట్రా ఉండదు. ఫర్ ఎగ్జాంపుల్, there might be many containers where ping also doesn't work. We use ping, right? Okay, you get into the any operating system, Linux or Windows, and if you want to see whether the networking is working or not, what we do, we use a ping, and then we ping google.com or yahoo.com to know whether internet is working or not. There are many containers where even ping is not present. The reason is my application doesn't use ping. Why do I need to have it? That's the whole point. So we will have only whatever is required for our application to work, not the additional tools. Okay, so sometimes your administration might become challenging. That's the whole point why you and me are learning this. Okay, are we good now? So now let me go back to my question. What is a container? Container is an isolated area of execution for applications. That's what a container is. Why is it required? Because it is an effective way for utilization of resources on your physical server, right? How does it help? On the same, I can reduce costs, and on the same physical machine I can launch many containers, right? With VM, let us assume I am launching 4. I'm just being mathematical. I can at least launch not less than 7 to 8 containers which are of the same applications, because I'm reducing operating system overhead. So does it make sense now? Right? So this is what this technology is. This is what this technology is. Right? Now, what is Docker then? What is Docker then? Okay. So let me tell you a small history about Docker. Docker was a company which was working on PaaS services, platform as a service for cloud applications. So whenever they were doing this to test whatever they were working, that company was called as .cloud. Okay. To test whatever they were developing, they needed some sort of isolated areas. So for that, to test their PaaS applications, they have developed this Docker technology. But what has happened was, no one was interested in the PaaS technology what they were developing, but everyone was interested in this container technology. So the .cloud became Docker Inc. The company's actual product was not Docker, it was something else. But to test that actual application, they have started on something called as Docker. Now Docker has become more famous, and now the company's name has been changed to .cloud to Docker Inc. So that's the basic stuff in here. Okay. And container, I'm not saying that the Docker is the only container. Docker is the best container, or Docker is the famous container. Even Google has containers. Whenever you do Google search, you are using containers already. You are using containers already internally. But those containers, I'm not saying are bad, but not famous. Docker is very much famous in all the worlds. Right? So Docker is basically an application which will help you to create containers easily. That's it. Nothing beyond it. Docker is nothing but a application which helps you to create these containers. That's it. That's the whole point. Right? Now, let us go back to this slides. Now, is it making sense? From the physical server, VM is far better. Okay. From the VM, containers look better when your concept is application. When your concept is administration, you will have a lot of problems here. Okay. When your concept is administration, you will have a lot of problems. Okay. Now let me take questions. Yes, you had some question. Yes, it can be anything as of now. But when it started, it was just Linux. You can. They are isolated areas. Okay. I'll show you a small demo. All right. Okay. Okay. Docker ideally is used to reduce the hardware and operational costs. Okay. That is how it started, but it gives you more than that also. Okay. If an app 1 requires Windows Service Pack 1 and an app 2 requires Windows Service Pack 2, how can we achieve the containers? Why an app requires Service Pack 2? Can you tell me why does an app require a Service Pack 2? Because of some installation, right? And I'm saying that you are an isolated container, all right? And whatever software which you have will be in your isolated container, not on your parent operating system. So you can get your isolations, right? And whenever you are saying Windows containers are not as strong as what Linux containers are. So I'll not be taking Windows examples as such too much, because Windows containers are good than what they were before, but there is still a lot of things to be done. All right. Okay. So let us assume I will put this in a different way. Okay. I will convert that question into Linux now. Okay. My one application requires, okay, CentOS 6 kind of environment. One application requires CentOS 7 kind of an environment. How can I get that? You will be able to get that because you are getting an isolated area, and in that isolated area you will be installing, or you will be having whatever is required. A container blue box ఉంది కదా, దాంట్లో 6 కి సంబంధించిన ఉంటాయి. In one container we will be having whatever is required for 6. In the other container we will have whatever is required for 7. That's how we make isolations, right? Okay. We have other ways to send data. For example, through XML, can we request a Docker container can speak to the other Docker container just like how a virtual machine speaks with other virtual machine. How? Using TCP, using HTTP, and there is no difference there. Okay. For example, if I want to send a data, if I want to call a website, what will you do? You will go to the Chrome browser and you will type http://google.com. So whenever you want to speak from one container to other container, the way is you use the standard communication protocols, which is how you communicate even today in VM, right? Okay. Can we run Windows and Linux app on each container? Okay. So let me try to tell you. When I say why is operating system coming here? What was all of my perspective? Name మాట్లాడుతున్నాను, application మాట్లాడుతున్నాను. Tell me an application. I'm not interested in your operating system. That's the whole concept of container, right? So for example, I want to run .NET application and a Java application. Tell me that, I'll be able to answer. I am not interested in operating system anymore, right? Can I do this? Yes, it is possible. Can I run a Java application and a .NET application using containers on the same physical machine? Yes, it is possible. Okay. I don't want to speak operating systems. The whole reason for the both of these container technologies, you avoid those operating system conventions, right? So yeah, but when it comes to Windows containers, there are certain things which are slightly different. So I don't want to speak much about Windows right now, because the way Windows work is Windows containers works only on specific operating systems. Okay. Windows containers works on anything which is greater than Windows 10 and Windows Server 2016. If your operating system is anything other than that, 12 also, I think 2012 also it will work, right? Other than that, you cannot use Windows containers. Okay. And it is still under development. So Linux containers are stronger than Windows containers, right? Okay. Why Docker is famous compared to other containers? I don't know the reason, but somehow it has caught lot of attention. Okay. Really, there is one more container called as Rocket containers. Even they are good, but somehow technically I don't see any reason, because they also have all of this, right? So why is Microsoft Word more popular than Google Sheets? I don't have an answer, right? Exactly in the same way, right? But technically, right, we have gone beyond a point basically where Docker is equivalent to container. Docker anna container anna synonyms ga చూస్తున్నారు. So that's how it has caught the attention. There is no other reason for it. Actually, in Linux, there is from Linux you can create a container which is core Linux container. No other operating system, no other what do you say, additional software is required. From Linux, you can create a container, but even those are not popular. All right. Yeah. Okay. Why does licensing cost not incurred when spinning up multiple OS containers? Again, I am coming back to the same point. I'm not worried about OS container. Don't call it as a OS container. Tell me the application. Container is not about operating system. Container is about application. అడ్మిన్లతో నాకు డాకర్ క్లాస్లో ప్రతిసారి జరిగేదే ఇది. I'm not new to this. I've been, I think it is approximately my 15th or 20th Docker discussion. Okay. Somehow admins become emotional about operating systems, right? So you have to start thinking beyond it. Tell me your application. I'm not worried about your operating system. You already have one. Why do you want one more? You already have a one parent operating system. Why do you want to have one more? That's my question around it. Are we good? Yes. Okay. How is licensing of the OS reduced? Because I'm not installing it. Otherwise, in VM, what is that we used to do? I used to install VM, and on the VM I install operating system. So for these four applications to work, I would have four operating systems. Assume four are Red Hat enterprise versions. Then 4 into $49 for, let us assume. I'm just doing a simple math. So approximately $200 is what you are saving already. All right. Okay. How many Docker containers can be created in a machine? There is no limit. It is your system's what is it? System's power actually. Okay. For example, if you have a huge system, you can create many containers. If you have limited system, then limited free space or limited RAM, then you can create less containers. It has no limit actually. Okay. If don't call, I said like, I'm not answering Windows or Linux. Tell me applications. Tell me what your application requires. Okay. And by the way, for the people who are thinking of .NET applications, even .NET Core has came up where .NET works on Linux now. Okay. Satya Nadella started loving Linux, so I don't see a reason why you should start loving it or stop hating it, right? Microsoft last year has done one conference where there was a very huge banner which says Microsoft, and then there was a huge heart which, and then there was Linux, and that was a conference between Microsoft and Red Hat. Okay. If Satya Nadella has no ego, then why should we have? All right. SQL Server is working on Linux now. Okay. .NET is on Linux now, but we are still on Windows. All right. It's time to move. It's time to move on. That's why Microsoft's revenues are increasing. Okay. Suddenly Microsoft is becoming open source and closer to Linux worlds, but we are still at the older Microsoft, the Steve Ballmer days. Right. Okay. Can you please help me in main differences of configuration management system and containers? Does the configuration management system and container fit in DevOps world? Nagaprasad, I would recommend. Have you attended yesterday's demo? Right. So if you have attended yesterday's demo, I have drawn some boxes. Right. In that boxes, I said that you will be building and compiling the code or compiling and packaging the code, and then you would be preparing your test environments. Now you don't do all of that in the Docker world. You would just create a container image, and then you would be running your container. As simple as that, right? So if it is non-Docker environment, you still need configuration management because you are working with operating systems. Okay, you deal with operating systems. That's the difference. That's why you need it. In the container world, there is no importance for underlying operating system. No, not at all. Okay. In the container world, the importance is for the application which you are running, not for the operating system, and whatever your application requires. So for example, if my application requires to send an email, so in my container I will have some necessary functionality which can send email. If my application basically sends an SMS, so necessary infrastructure that is required for my application to send an SMS. That's it. So my focus is not on operating system capabilities. My focus is on application capabilities. That's what it is. Right. Does Red Hat kernel cost? I think we'll have Linux kernel, right? Red Hat is an operating system. All right. Red Hat operating system on an enterprise version costs. So that's why they have came up with something called as CentOS or Fedora based, which are mostly CentOS is very much closer to how the Red Hat works. So if you don't want no OS cost, go with CentOS is what the Red Hat community is basically an answer for that. Is there any chance that Docker has failed? Dockers have failed? Not any chance. They fail daily if you don't configure it correctly. There is 100% chance that Docker containers can fail. Okay. It depends on how do we configure it. How do we configure it? Right. Are there any limitations regarding the application, that is particular applications that are possible to place in? Yes. I am coming back to that point. All right. Okay. Is Docker applicable only on cloud? No, it can be installed on any operating system. Linux, Mac, Windows. Any operating systems, you can, whether they are server or client versions, you can install or make it work. All right. Yeah. That's the whole point. That's why we don't use Red Hat OS. That's why we use kernels. If you are using Docker, don't we need to have configuration management tools? The use of configuration management tools is almost reduced when you go with Docker, when compared to what we do with the physical machines or a Linux based operating system deployments. Okay, the need of it is reduced. I will not say it is not needed. It might be, but even if it is needed, it is very less. Okay, fine. Now, in the Docker, the question is, what are the kind of applications which I can put? You can put any server or service based applications. You can put any server or service based applications. On the Docker container, I can have web server. On the Docker container, I cannot have Microsoft Word, because Microsoft Word is not a server or a service. It is an application which has to be installed. So Docker is replacement for server or services, but not desktop applications or mobile apps. No. Okay, it is used for the service world, the backend world. Okay, so on the Docker container, I will not have Chrome. Okay, I'll not be using Docker container for Google Chrome, Mozilla Firefox. No, those are all front end applications. It is all for middleware and backend kind of applications. Yes, containers are not for front end applications. If you want front end, go with the traditional VM stuff itself, right? Or use your desktops. It is all server or service based applications, right? Okay. Now, the last concept which I want to discuss, I think you can go through this. This is already shared. Okay. For the people who are new, go into qualitythought.in/blog. Okay. You will be seeing DevOps new material. Click over here, and then you would see this list of all the um, slides which I have, all the slides or whatever it is which I'll be using in the class. Not only for Docker, you will have it for everything. Okay. You'll have everything. So just click on the Docker stuff and you would be seeing whatever presentation which I have opened in the class. So for example, this I have opened from here itself. Okay, not this. This. Okay. So everything is over there. You can go and basically have a look at it. Right. Now, let me define something which is very important in the world of Docker, and that is called as a microservice. Microservice. Right. So Docker is the best way to go with microservices. Okay. I'll answer why it is at the later point of time. Okay. I'll write one more advantage of Docker. If your application has been containerized or Dockerized, whatever you call it, okay, you can move to any cloud easily. So let us assume your company has not moved to cloud, but they are using applications. Those applications you have containerized. You have basically your applications are working in this Docker containers. Then it is very simple for your applications to go to cloud. Right? So all of this is looking good. Then what is your and my job in Docker? Why are we learning it? What is that? What is that is expected from you and me as a DevOps engineer in the Docker world? First thing is, your and my responsibility is to containerize applications into Docker containers or containerize application. I'll not say into. Okay. So the application which your company is currently developing might be working on, you need to do all the steps which I have said discussed. But actually, the first responsibility is you should be able to containerize that stuff. Okay. What do I mean by containerizing your application? Making your application, or basically making whatever is needed for your application to run on Docker. That is containerizing. That is the first thing. And the next thing is orchestration or clustering of containers. These are the two responsibilities. First, your company will tell that, okay, this is my application. I want to run it in Docker. Your first responsibility is first containerize it. Okay. So what do I mean by containerization? What do we do over there? That is something which I'll discuss in the next class. But these are our two responsibilities. Containerize. The next one is orchestrate or cluster those applications. So for example, your application will not be one container, it will be many containers. So how do you ensure that all the multiple containers are working closely with each other? So how can you do that? So that's the orchestration part. Okay, for the second part, okay, there are two major stuffs which we can use. One is Docker Compose, the other one is Kubernetes. My focus will be on Kubernetes. My focus will be on Kubernetes because that is the most popular orchestration or a clustering Docker container clustering framework. Okay, there is no debate about it. Kubernetes is the best one, but there are many. Okay, so for example, there is something like OpenShift, Nomad, many things, but Kubernetes is the best and the foremost one. So that's why we are using that. Okay, yeah. And for containerizing applications, we'll be learning all the Docker concepts that are necessary. So we'll be learning something like Docker, and in the Docker, we'll be learning networking, okay, storage, images, etc. There are many other concepts. Okay, so these are the two responsibilities. So by the end of this course, what you would be able to do is you would be able to give an application, you would be able to containerize it, okay, and then you would be able to run multiple containers in an orchestrated fashion. Okay, so because now you will have just applications. Okay, so once I define microservice, I will be adding some more things to it also. I'll be adding some more things to it also. So now what is a container? It is an isolated area of execution. Mana application run avvataniki ememaithe kavalo avanni oka closed area lo. Okay, so imagine for the people who are finding it difficult to understand the container, I'm quite sure that you might have seen a lot of containers near the shipyards and all of that stuff. Okay, the Docker uses that shipyard terminology a lot. So even if you go to the Docker, you will be seeing that ship, and Kubernetes is also one of the ship's basic unit. So all of the Docker uses that stuff. So in the container, okay, you are present. So you are isolated from the external world. Yes or no? Right? Similarly, in the container, you have your application. And whenever your application wants anything, it will ask container. And container will get it done. How it gets done, let us wait for till the next two classes to understand that. Right? So that is what a container is. You will have a container which is an isolated space, and in that isolated space, you will be executing your applications. Right? So now your company will developers will be developing whatever application which they are doing, and once they develop that application, we will take that application and we will containerize it. We will ensure that that application runs in Docker, and then we will deploy it. Once it is in Docker, the best part is you can run it anywhere. You can run it anywhere. So let it be cloud, let it be physical machine, let it be virtual machine. It doesn't matter from there on. It doesn't matter from there on. Right? So I'll be showing you a small demo before basically I do it. Okay. So let me go into. Okay. Okay. So yesterday I said that for continuous integration, we will be using a application called as Jenkins, right? Yes. Now, if I want to install Jenkins, the normal steps are you have to install Java on your machine, right? And then you have to install Jenkins on top of that, all right? Now, let me basically go at some point. What I'll do, just don't worry about the commands which I'm typing. I'm really not worried about the commands, but let us see what happens. I've just run one command. Okay, I'm not installing Jenkins on my machine. I'm just executing one command. All right. So see what is happening. You will be understanding all of the terminology in the next class. What is that pull, right? What is it? What is the stuff that is happening and all of that stuff? Okay. I have Docker installed on this machine. Okay. And then I'm executing some command in the command line. Okay. Let us see what would happen once it finishes it. I should have taken the smaller application. Okay. Fine. Let me take one more smaller stuff. Is it done? This is happening on Quality Thoughts network. So obviously it will be slow. If you go to the AWS cloud and do the same operation, it would have been up by now. That is our network speed. Good. Continue. Yeah. Yeah. I'm sorry, I'm keeping you waiting, but I had to show this. Okay. Pardon me? Yeah. Yeah, please go ahead. Mm. Both applications in the same container. Yeah, you can. You can do all of that. You can do all. That is the whole point of orchestration. Yes. Now let me do localhost colon 88. Okay. What is the IP address of my machine? VirtualBox adapter, Ethernet. Yes. 192, 168, 1.26. 192, 168, 1 dot. What is happening? What is the command which we have given? Okay. Every time I think I'll have the same problem. I think. Oh man. Okay. I don't want to get into internals of how I'm fixing this. Uh, but unfortunately, yes. Where is network? Advanced port forwarding. I shouldn't have done this. This is a problem with Windows 7. Okay. In Windows 10, you don't have any sort of these settings to be done. Okay. Now let us see. This is an issue with Windows and some sort of networking company. So, do I have Jenkins now? Yes. Is the Jenkins installed on my machine? No. It is in the container. Okay. So, if the Jenkins is installed on my machine, if I do Control C, I've stopped the container. Okay. And I execute localhost colon 8080. See what happens. Okay. Is it stopped? Okay. 1 minute, guys. Docker ps. Oh, it is still running. I didn't want to run all of these commands. Sorry, I'm extremely sorry for that. Okay, but you will be knowing all of this, whatever I'm doing over here. Okay, it is just a matter of time. Okay, now let us see this. Local host, is it working? If it is installed, it should be working every time, right? Okay, now I want to run this. I execute the same command again, but don't worry, this time it will not download. All right, now I'll use the same thing. Okay, just wait, it will be started. Are you seeing something happening in the background? Okay, so basically what is happening is nothing is happening on your system actually, right? On your system a process is created and that process starts working, and when that process is working it will give whatever is required for your system. All right, and I have used some commands, but don't worry about those commands. You and me will be learning that very soon. But the whole point is, now this is an application which is in Java, right? Let us assume it is using Java 8. Right, now I want an application which runs on Java 6. Is it possible on physical machines? Yes, but it is difficult. Every time you have to change the path variable and then you have to run that applications. But here you don't need to do anything. You have to just run one more container, the docker run command, whatever I've copied, just put it in your CLI and start working on that. What would happen is an isolated container is created and whatever is required is in that container, not in your system. So whenever you are creating an application which requires Java, you are not installing Java on your machine. You are creating a container which has Java. You are creating a container which has Java 8, which has Java 9, which has Java 10, whatever it is. Okay. So on the same physical machine, even without installing Java, you can run multiple containers which require Java. Same thing with Python. Same thing with .NET. Anything. The whole point is you are not installing anything on your machine. Anything on your machine. So for example, you want a MySQL database. There is a container for MySQL. Just run one simple docker run command and you will get you will get MySQL database on your system. Finish using it, kill the container, everything is gone. You are not installing anything on your machine. So with the container, the best part is you can use multiple services without installing them on your machine. So for example, I want an Nginx web server because I'm deploying some website. You really don't need to install Nginx. Just execute a docker run command, which will bring you basical Nginx, work on it, finish your work, just delete it. Nothing on your machine. Nothing on your machine. Right? So for example, you don't need to have any software installed on your system. The only software that is required is Docker. The only software that is required is Docker. Okay. So for practicing Docker, for the how many of you are on Windows? Okay. I would recommend if you are on 7, please try to move to 10. Try to move to 10 because Docker for Windows 10 it works natively. Works natively. On Windows 7 it is quite stupid. It will fool you. Windows 10, 7 it will fool you. I'll tell you how it will fool you. Whenever you install Docker on Windows 7, what would happen is it requires a virtual box, which is a hypervisor. Okay. And if you remember, I have gone into this box, right? And I was just doing something over here. Default. Do you know what this default is? This default is a Linux machine. So basically, whenever you are running Docker on Windows 7, Windows 8, you are not running Docker on Windows. Actually, you are running Docker on Linux. Okay, because what Docker does is it will create a Linux virtual machine. In that, it will install Docker, and then you are whenever you are running any commands, you are not running Docker on Windows. You are running Docker on Linux. It is an illusion. But if you go to the Docker on Windows 10, it works on Windows. It works on Windows. So I would recommend for the people who want to use Windows, go with Windows 10. If it is Mac or Linux, wonderful. There is no need for you to change anything. Our classroom samples will be more towards Linux. Okay. I will have one separate session for Windows containers. Okay. But that is not during this point. That is during Windows DevOps. When we discuss on Windows DevOps, I'll be discussing about this. Not now. Right. Okay. Now let me look at the last set of questions. I'll see how many I can answer. I'll not keep you waiting. Let me come back. Uh, what is microservice? Sir, that is a pre-cap of tomorrow's episode. I'll start my class with what is microservice tomorrow, right? Because it is just not a definition. It is a behavior. You need to understand about it, right? In real time, Docker containers are used in production or only in dev. Many companies are using it in dev or test environments, but eventually they want to move to production. There are many companies which are using it in production also, right? Yeah. Does abstracts are covered as part of this course? Can you be more elaborate? When you say abstract, what do you mean? Right? Like a good strain, bogies. Yeah, you can think of it. Okay, that is isolated from the other bogies, right? Once you have a container. Yes. How to run Jenkins directly in Docker? You don't need to install Docker, right? Yeah, you need to install Docker. On my machine, Docker was already present. All right. Where is container getting created? Let us see it tomorrow. All right. Because we need to understand microservice, and I will be elaborate explaining you some concepts of Docker containers, like what is that pull, what does it run, and whenever you have run, we have seen something like pulling image. What is that actually meant by pulling the image? What happens then, right? And then I have used something called as minus p, and whenever I copied, there are many things over there. We will understand then, and then we will be looking into where the containers are. All right. Without installing Java in Docker, how to run it? Please elaborate. Without installing Java in container kadandi, Java in your system, on your operating system. Jenkins will not work without Java. Okay. The whole point which I'm trying to tell is you don't need to have Java on your physical machine. Java is required only in your container. Java is required only in your container, not on your physical machine. Does companies use yeah, that, as I said, there are companies who are doing that. There are companies who are moving towards it. Okay. So this is caught lot of attention. Okay, because it saves a lot of cost for your organization, right? And once you have developed or you have containerized your applications, you can take it to any cloud, right? From AWS to Bluemix, you take any stuff, IBM cloud, Oracle cloud, Google cloud. For any cloud, the Docker is the most easiest way to go, right? So that's why it is very important, right? Then, so I'll be stopping my class over here. We will meet tomorrow. But one thing, if tomorrow is Ramadan, by any chance our class might be on Saturday, right? So you will be getting SMS. So for the people who don't have your details, or quality thoughts doesn't have your details, please give it to them. If tomorrow is not Ramzan and Saturday is Ramzan, we will not have any change. We'll have our class tomorrow as usual. So for the next 2 days, we might have one holiday for sure. Whether it is tomorrow or day after tomorrow, I'll be knowing only by end of today. So I'll not be able to tell it upfront. All right. Pardon me? Yeah. No, Google. Docker has something called a Swarm. Okay. And there are many. For example, there is Nomad. There is Tutum. A hell lot of things. I installed Docker on Windows, but Windows fools you by creating a virtual machine. కరెక్ట్, వాస్తవం అదే. కానీ డాకర్ మీరు ఇన్స్టాల్ చేసినప్పుడు అది మిమ్మల్ని ఎలా ఎదవం చేస్తుంది, అదే వర్చువల్ బాక్స్ ఇన్స్టాల్ చేశారు. It will install if it is on Windows 7, not 10. That's what I was trying to tell. So Windows 7 is not Docker on Windows, it is Docker on Linux actually. Yeah. Yeah. Thanks. Yeah. You can install Docker anywhere. Anywhere. Docker can be installed even on Raspberry Pi. If you know what Raspberry Pi is, a small device which you might have seen on the circuit. It looks like a circuit, so you can install it anywhere. We'll discuss about it. ఫస్ట్ రోజు సెక్యూరిటీ చాలా ఎక్కువ పెద్ద కాన్సెప్ట్ కదా మాట్లాడటానికి. రైట్, యా. How does Docker use the package and use it in cloud or physical or environment servers? Shiva, I'll be able to answer it probably. Basically, what you do is, what were DevOps responsibilities in Docker? Containerizing the applications and orchestrating the applications. The question which you have asked is actually the whole containerizing the applications part. అంటే డాకర్లో మనం చేయాల్సిన పని అదే. You and me are paid in Docker just because you and me are basically supposed to convert your developers applications into containers, right? If it is how is basically 3 to 4 days of class, so I cannot tell in one line, so we'll be doing that, right? Okay then, so I'll stop it at that, and let us meet either tomorrow or day after tomorrow, and Satish will be sending you the mail in the evening today. You will not be able to do it upfront, right? Yeah, thanks for your time.